Now we'll go over the procedure for finding probabilities. As we go through the steps, you need to write these down so that you can use them when you're working problems. First, after reading the problem, you'll want to sketch, label, and shade the curve, the normal curve. You'll sketch the curve and mark the mean and label that, and then find your x value on the number line and shade the area or probability that you're trying to find. Then you'll convert your x, your value of interest, to a z-score rounded to 2 decimal places. This is where you'll use the z calculation, the z formula. Then you'll take your TI 83 or 84 calculator and use the normal cumulative density function to calculate the probability, putting in the low value, comma, and the high value off of your diagram that you've sketched. And the calculator will then give you this area or probability, and you'll round that to 4 decimal places. Okay, when you enter negative infinity, obviously that's not a button on your calculator, so we'll use -5 representing 5 standard deviations below the mean, which we know is way out there, and there's just a teeny bit of area beyond that. And we'll use +5 for positive infinity. Okay, now you'll get your probabilities rounded to 4 decimal places. And then you'll write a sentence or two interpreting your results. Okay, now we want to look at an example where we'll go through these steps. So hopefully you've written these down so you can follow along. Okay, the weights of men are normally distributed with a mean of 172 pounds and a standard deviation of 29 pounds. So let's make a note of that. So we know that our mean is 172 and our standard deviation is 29. Okay, we are to find the probability that a randomly selected male weighs less than 174 pounds. Okay, so we'll use a diagram to get an understanding of this. Sketch, label, and shade the curve. Okay, here's the mean. We were told the mean was 172. Okay, these are what we call our x values along here, the weights, and then our particular one of interest is 174. Okay, so that would be to the right of 172. I'll just draw that right here. Okay, here's 174. Okay, so now what I want to do is shade the area I'm looking for. Well, what I'm looking for is less than 174. Okay, so that area, by shading, I'm just going to cross hatch. You can shade or do something similar to this. This is the area I'm looking for. Now let's stop and use some critical thinking. The mean is right here in the middle, where 50% of the weights of males are below 172. So I know this area from way out here, from negative infinity all the way to the mean, that represents 50%. That area is 0.5. So I'm going a little further than that. So I know right now, I can tell you that my probability is going to be a little bit higher than 0.5. It's a good idea to know where you're going, what to expect. Okay? So now what we want to do is convert our x to a z-score. So our x in this part is 174. So z is equal to our value x minus the mean over standard deviation. 174 minus 172, and of course we're going to get a positive number because we're above the mean, over 29. And this is not much above the mean. We get approximately, rounded to 2 decimal places, 0.07. Okay, so that's the z-score for 174. Now we'll use our calculator to find the probability. So let me get some notation down here so I know what I'm doing. I want the probability that x is less than 174. To do that, I'm going to find with my calculator the probability that z is less than 0.07. And I'm going to use the normal CDF low. Now when I look at my graph here, the lowest value, well, it continues on and on to negative infinity, and we said we're going to use -5 for negative infinity all the way up to the z-score there. So let me label those. So the mean z-score is 0. The z-score of my value of interest is 0.07. So I'm going all the way to 0.07. Okay, so now we'll look at our calculator and go to our distributions, second key, distributions. Let's see, this one's not on. Let's turn that on. Okay, second, distributions. All right, I want the normal CDF, so I'm tabbed down to the second function here, enter. And now what I have to put in is my -5, comma, 0.07, close parentheses, enter. Okay, and I want my probability to 4 decimal places. It's 0.5279. 5279. Okay, so we found our probability to 4 decimal places, and now we want to interpret our results. And what we would say is there is a probability of 0.5279 of randomly selecting a male with a weight less than 174 pounds. Okay, and we said it would be a little bit more than 50%, so if we change that to a percent, we get just about 53%, 52.79. So that should all make sense to us. Okay, well, let's look at another way we can continue with this problem but be asked something different. Find the probability that a randomly selected male weighs more than 180 pounds. Sketch, label, and shade the curve. Here's my mean, and remember our mean was 172. And my value of interest is 180, so again I'm on the right hand side of the mean. Okay, these are my weights, and then we'll be changing these to z-scores. So I'm going to go ahead and show that my mean z-score is 0, but I'll be calculating a z-score for 180. And now let's shade. The probability that a randomly selected male weighs more than 180. So now I'm going to shade on this side. This area represents the probability. And the total area under the curve is 1, right? So on either side of this symmetric graph is 0.5, or 50% of the area, 50% of the probability. I haven't even shaded all of 1/2, so this must be less than 50% or less than 0.5. That's what I'm thinking. That should make sense. So if I get something different than that, I should question it. Okay, so now let's change our x value, which our x value is 180 this time, to a z-score. If you'll write the formula you need every time you use it, by the time you take a test you'll know the formula. Okay, 180 minus 172 divided by 29. And this time we get a z-score of about 0.28. 0.28, because I'm rounding to 2 decimal places. So what do we want this time? This time we want the probability that the weight, some value x, is greater than 180. Okay, and here's my z-score at 0.28 for 180. Well, that's the same thing as the probability of finding the z that's greater than 0.28. Okay, so I'll use my normal CDF function, low to high. Well, this time the low value is my x value, 0.28, comma, and then this implies we go on and on and on to positive infinity, and we're going to use 5 to represent positive infinity. Okay? So we'll look at our calculator. Okay, this time go to our distribution, tab down to the second function, normal CDF, and this time we're entering 0.28 as our low and 5 as our high. Enter, and we get 0.38973, which would round to 0.3897. Okay, and now all we have left to do is our interpretation. There's a probability of 0.3897. Of randomly selecting a male with a weight more than 180 pounds, of more than 180 pounds. Okay. So we've seen one where the probability was below a number and one where the probability was above a particular value of interest. And now we want to see a third type of problem. Continuing with our weights of males, find the probability that a randomly selected male weighs between 160 and 170. Sketch, label, and shade the curve. Okay. So our mean is 172. These are our weights, our x values. 160 and 170. Well, both of those values are to the left of the mean. So let's see. There's, we'll say that's 170. Not a very good job there. And 160. Okay, we know they're both to the left of the mean. And now let's shade our area. Okay, so a little slice right here, obviously less than 0.5 or 50%. Okay, let's find our z-scores. Of course, for the mean, it's 0, but this time we're going to calculate two different z-scores. We won't be using -5 for negative infinity or +5 for positive infinity because our low and high are right here, 160 and 170. So I need a z-score for 170. So 170, they're both going to be negative, right? Because they're both below the mean. So the z-score for 170 turns out to be negative 0.07. Not very far below the mean. And then my z-score for 160 and that one turns out to be negative 0.41. So let's put those on here. Here we have negative 0.07, negative 0.41. Okay, so what are we trying to find this time? We're trying to find the probability that some value x is less than 170 but greater than 160. So that's the same thing as finding the probability that our standardized value, our z, is less than negative 0.07 but greater than negative 0.41. See, I can just look here and see them. I've written it on the graph. There should be, this will keep me from making a mistake. I can see my values right here. I know I'm putting my z right between them. Okay, so this is, we'll use the normal CDF, and now my low is negative 0.41, comma, negative 0.07. Okay, go to the second function, normal CDF, and this time I'm putting in negative 0.41, comma, negative 0.07. We said this should be less than 0.5, and it's significantly less than 0.5. 0.13119, rounding to 4, that says I'm going to round this 1 up to a 2. 0.1312. Okay? And now our interpretation, there is a probability of 0.1312 of randomly selecting a male with weight between between 160 pounds and 170 pounds. Now all these interpretations, another thing we can always add is, in other words, about 13.2% of adult males weigh between 160 and 170. That's what we're really saying, because this is, we're talking about our whole population here and randomly selecting someone from the population. So in other words, there's a 13.12% probability or chance that any randomly selected male has weight between 160 and 170, because 13% of the population, of the male population, does weigh between 160 and 170.